Alright, let's look at 4.2. Before we start out with the first problem, let's look at the one difference between 4.1 and 4.2. Everything you see here is things that you know how to do from 4.1. Everything here is finding the x and y intercepts, finding the corners, graphing it, shading the right region. This guy right here is the only difference. They got an equation they want you to maximize. So what you do is you take all these corners that you found and you check each one with the x and the y in the original maximize function. And since it asked you to maximize on this one, you choose the largest number, max. That's the only difference between 4.1 and 4.2. Is this taking those corners and plugging them into the equation and choosing the largest or smallest one. Alright, so let's look at 4.2. Question number 1. Okay, they start with the first question starts with just the last part, which is they already found all the corners for you and they just want you to check them with the equation they give you, and they want you to find the minimum and the maximum. Minimum is 0, maximum is 76. When you plug in 0 for x and 3 for y, 6 for x and 2 for y, and so on. They do the same thing with number 2. They give you the corners already and you plug them into this. You pick the largest and smallest. Okay. And number 5, they don't give you the corners, so you have to do some work to find all your corners here, x and y intercepts and a couple of floating corners out there. And now you take all of them and plug them into this guy and find your minimum and your maximum. Number 9 is the one that I started with. Okay, they give you these lines and you graph them and shade the right region and you find the corners just like we've been doing before, right? So you take each of those corners and you plug them into this function they give you, and you choose, in this case, to maximize it, so choose the largest number. For 12, they give you nothing. You have to graph every single one. You got to find every single x and y intercept and some corners here. And then once you're done, you take this minimize function and use all those 4 corners that you have and plug them into that function, and you choose the one that's the minimum in this case because they ask you to minimize. So notice you don't choose every single point where things cross. You choose only at the edge of the shaded region. So you pick 10, 0, 8, 1, 2, 7, and 0, 11. You don't choose 0, 9 or 0, 5 or this one here or even that one there or that one there. It's got to be right along the edge to count as a corner. And 13, same idea again. You got to graph those lines, find the corners, check the corners with the equation, maximize. So you're looking for the biggest one. 15, they give you 3. And notice they also give you x is greater than or equal to 0, y is greater than or equal to 0. That means the x and y axis are places that you have to consider. You have to actually put the arrows on the ends of each one and say this is x equals 0 and this is y equals 0. Okay, and so you've got a lot of points to check, and you plug those in and check, and you pick the maximum. You actually happen to have 2 maximums, this guy and this guy, and when they're right next to each other, that means not only are those corners maximums, but any point along in between them is also a maximum. One of the rationales in this type of mathematics is that if you're going to find a max or a min, it's going to be on the corners. Okay, so that's why we're focusing on all those corners here. Okay, and you plug those corners into the equation, and and you pick the minimum, in this case, min. At 20, you pick the min between these two numbers and your x and y. X equals 0, y equals 0. And you finally plug them into the equation, and you pick the one that's the smallest. Okay, and then 22. You got 3 lines here, and you find all the corners for them, the x and y intercepts for each one. You take your corners only and check them with the function, and you pick the maximum one. And then 23, you draw all 3 lines, and you get this shaded region here that goes out in this direction forever. And you only have 2 corners, this one and that one, and you check both of them, and you pick the ones that's smallest, which is 3100. And there you go, that's your answer.